Quicksort algorithm is one of the most used sorting algorithms, and it's the one that is built into most languages and frameworks. It's a fairly efficient algorithm, and unlike merge sort, it doesn't require any additional space. We can sort an array in place. Let me show you how it works. We start off by selecting an item, which we call a pivot. Then we rearrange the items such that all the items smaller than the pivot are on the left, and all the other items that are greater than the pivot are on the right side of the pivot. This is called partitioning. So we divide the array into two partitions that are separated by the pivot. Typically, we select the last item as the pivot, but there are variations of this algorithm where we select the first item or a random item as a pivot. We'll talk about that later. For now, let's select the last item as the pivot. Now we should rearrange the items such that all the smaller items are on the left and all the larger items are on the right side of the pivot. Here's one way to rearrange these items. So we have 6, 3, 1, and 10 in the left partition, and 15 and 22 in the right partition. Now, the order of items in the left and right partitions doesn't matter at this stage. For example, in the left partition, we could have 3, 6, 1, and 10. What matters is that all the items on the left of the pivot are smaller than the pivot, and all the items on the right of the pivot are greater than the pivot. And that means the pivot is in the correct position. So eventually, when we fully sort this array, 13 is not going to move. It's going to stay where it is right now. So when we pick a pivot and partition our array, the pivot will move to the correct position, okay? Now we repeat. We perform the same steps to the left and right partitions. So in the left partition, we pick the last item as the pivot and then reorder the items around this pivot point. In this case, all these items are smaller than 10, so we don't need to reorder them. We're done here, and 10 is in the right place. Again, we repeat. In the left partition, we pick 1 as the pivot and reorder the items. Now here's the interesting part. As part of reordering these items, we don't have to worry about the items in the right partition. So we have narrowed down the scope of our work. This is the reason why Quicksort has logarithmic complexity, because in every step, we narrow down the size of our partitions, almost breaking them into half, almost. So in the left partition, we should move 6 and 3 to the right of 1. Now, 1 is in the correct place. Again, we repeat. In this partition, we pick 6 as the pivot, but in this case, we don't need to rearrange the items because 3 is smaller than 6 and is on the left. So we're done with 6, and now we have a partition with a single item. We assume partitions with a single item are sorted, so 3 is in the right place as well. On the right side, we have another partition with 2 items. We pick 22 as the pivot. Again, we don't need to rearrange, so 22 is in the right place. And finally, we have another single item partition which is sorted, so our entire array is sorted. So this is how Quicksort works. Now, what about partitioning? How exactly are we going to move items around? We're going to talk about that next.